IrisLogic's YouTube channel. In today's video, we'll delve into a burgeoning topic gaining momentum within the DevOps and cloud realms: platform engineering. A buzz of conversation surrounds this subject, with questions arising about its relationship with DevOps. While some argue that platform engineering complements DevOps, serving as an extension, the reality is a tad more intricate than a simple addition to the equation. Join us as we explore the nuances of this evolving landscape. Platform engineering is a transformative force, challenging the well-established norms within DevOps, SRE, and cloud engineering. This paradigm shift introduces not only a game-changing dynamic but also ushers in a set of innovative rules. Let's embark on a journey to precisely define what platform engineering entails. Delving into the intriguing aspects, we'll explore the fundamental question: why did the tech landscape feel the imperative need for this distinctive role, and what spurred its evolution? As we navigate this exploration, we'll draw insightful comparisons with DevOps and cloud engineering, scrutinizing whether platform engineering serves as a mere addition or a potential replacement for these integral roles. When confronted with a novel role or concept, the primary inquiry should always be rooted in necessity. What underlying problems prompted the emergence of platform engineering? It's a testament to challenges that existing solutions failed to address, catalyzing the natural evolution of this role to bridge the gaps and solve problems that were previously insurmountable. Now, let's delve into the challenges that paved the way for the emergence of platform engineering as a solution. Initially, the landscape saw developers and operations operating in siloed teams. Developers bore the responsibility of crafting the application code. Once completed, they would hand over the packaged application to the operations team, tasked with deploying and running it. Despite having dedicated operations teams with expertise in managing infrastructure and overseeing company-wide CI or CD platforms, this conventional approach proved inflexible and sluggish. This process entailed developers waiting on operations for any required changes in infrastructure or additional resources, such as servers or Jenkins pipelines for their applications. Conversely, operations teams found themselves waiting on developers to address issues within the application that impacted deployment or application runtime. The inherent disconnect between these teams resulted in a bottleneck, impeding efficiency and responsiveness to the dynamic needs of both development and operations. The introduction of DevOps played a pivotal role in breaking down the barriers that had separated development and operations teams, dismantling the inflexible and constraining processes of the past. DevOps eradicated communication challenges and knowledge silos that existed between the realms of application development and its operation. This monumental shift marked a substantial improvement over the traditional working model. With DevOps, the transformation was evident as a unified DevOps team emerged, taking ownership of both the application and the underlying runtime and infrastructure. This consolidation not only streamlined the workflow but also fostered a more collaborative and cohesive approach, where the entire lifecycle of the application was managed seamlessly within a single, cross-functional team. Essentially, this entails overseeing not just the application itself but everything essential for its seamless operation. While this integrated approach brings about greater flexibility, speed, and an overall exciting work dynamic for engineers, it also introduces a plethora of responsibilities and cognitive load. In the realm of a unified DevOps team, the spectrum of tasks is extensive. Within this single team, you'll find either developers or dedicated DevOps engineers engaged in setting up CI or CD platforms, crafting intricate pipelines, writing Terraform scripts for infrastructure as code, orchestrating Kubernetes clusters, configuring them with best practices, and establishing logging and monitoring mechanisms. Additionally, there's the ongoing task of integrating security scans, maintaining Helm charts, and keeping all infrastructure code scripts up to date as tools evolve and new versions are released. This multifaceted role extends beyond the traditional boundaries of application development. The team is also tasked with managing Docker repositories and various other components, all in addition to their primary focus on developing the application. While this approach significantly enhances flexibility, speed, and efficiency, it inevitably imposes a considerable cognitive load on the team, as they juggle multiple responsibilities that were traditionally handled by distinct roles. And this complexity extends even further. Consider another application team working on a completely distinct project facing similar challenges and tasks. In an effort to enhance efficiency, a DevOps engineer crafts a comparable CI or CD workflow for the project. They set up a cluster, opting for a managed EKS service this time, configure all integrations with the AWS cloud, address storage considerations, implement security scanning steps, oversee secret management, and more. Perhaps they choose a different Docker repository like ECR for seamless integration with the EKS cluster. Despite the common challenges, each team tackles these tasks in its unique way, utilizing its preferred tech stack. Now, envision having 10 more such teams within your organization, each grappling with the same challenges and requirements for their applications to run successfully. Inevitably, each team devises its own methods and adopts a distinct technology stack. The result is 10 DevOps teams independently constructing and managing 10 different platforms to deploy and run their applications. This decentralized approach can lead to significant inefficiencies, wasteful resource utilization, and an elevated cognitive load on individual engineers within those teams. The need for each team to reinvent the wheel, so to speak, poses challenges in terms of standardization, collaboration, and resource optimization across the organization. In the realm of complex systems like Kubernetes, managing infrastructure can sometimes overshadow the effort put into writing application code and crafting business logic. Teams find themselves immersed in building robust platforms, leaving limited time to generate the desired business value within their applications. Moreover, the need for diverse expertise within a single team, responsible for overseeing the entire infrastructure stack beneath an application, translates to the requirement for many seasoned engineers. This, in turn, results in higher human resource costs. As organizations grapple with these challenges, scalability becomes a concern. Each new project team invests initial time and effort in setting up infrastructure before releasing applications to end users. Crucially, despite individual teams managing their infrastructure and platforms, there's a potential shortfall in expertise. This may lead to Kubernetes misconfigurations, gaps in monitoring and logging, and security issues across systems. Furthermore, when a company has a single compliance or security team overseeing multiple projects, each employing different technology stacks and diverse operational approaches, providing insights and ensuring proper security implementation becomes a formidable task. The complexity introduced by distinct tech stacks and operational methods across various teams can create significant hurdles for centralized security and compliance efforts. This dynamic necessitates a broad spectrum of expertise within individual teams managing the entire infrastructure stack beneath their applications, leading to the need for numerous experienced engineers and subsequently higher human resource costs. Scaling becomes a challenge as each new project team invests considerable time and effort in setting up infrastructure before releasing applications to end users. Despite teams managing their own infrastructure and platforms, there's a risk of lacking expertise in specific areas, potentially resulting in Kubernetes misconfigurations, inadequate monitoring and logging, and security vulnerabilities across systems. With a centralized compliance or security team and numerous teams employing varied technology stacks and operational methods, providing insights and implementing consistent security measures becomes a daunting task. The absence of standards, coupled with different technology stacks and configurations across teams, introduces inconsistency throughout the organization. In the current landscape, expecting developers to seamlessly embrace the you build it, you run it concept, involving intricate tasks like configuring Kubernetes clusters, can be impractical and inefficient. This presents a dilemma. Autonomous DevOps teams offer speed and flexibility but also bear overwhelming responsibility and create organization-wide inconsistencies. So to quickly summarize, we either have autonomous DevOps teams going wild and doing whatever is fast and flexible but also leads to too much responsibility on one team with high cognitive load and organization-wide inconsistency. Or we have the traditional separate dev and ops where infrastructure is managed and secured but with a painfully slow process that really limits the work of developers, and that's where platform engineering comes in to save the day. But only when implemented correctly. In the next video, we'll explore the importance of standardizing tool usage for enhanced collaboration and efficiency in platform engineering.